Okay, good morning everyone. Okay, so today, please join the class point first. Okay, we can so still didn't join the Google Meet.
Only Azure.
Sure, okay. So others, can you please join the class point? So my line slow, okay. Eugene, Abi, and another one is is here. Avinash is here. Who's another one other than Abi and also Krisha? All right. Okay, so I just continue first, okay, so you can join, alright. So Eugene already joined, so only Krisha and Abi. Alright, so 6.5, right? So for 6.5 is actually the optical instrument. So I already make a video, okay, for you to watch. So it's only the application, right, for the lens, okay? So microscope, I think microscope, telescope, and also the magnifying glass. So that's three applications. So you can watch the video, right? It's a very short video. Okay, how does the lens, okay, is being used for the microscope, okay, and also for the telescope and magnifying glass, and how does the image form, and how does the arrangement of the lens, okay, objective lens, uh, eye lens, right, and what is the characteristic of the image that being formed, and where is the object, okay, and what is the characteristic of the final image. Okay, so I already explained that one on the video, so I already assigned for you to watch it in the Google Classroom. So that one you can watch the video. Right, so now we're going to the last topic, okay, in the physics form 4. That is the image formation by spherical mirror. Okay, so you already learned how does the image form, okay, when it pass through, when the light pass through the lens, right? So now we're gonna learn what happened to the light, okay, to the light ray when it pass through the mirror. So basically for the lens, they use a refraction of light. Okay, so they use a refraction of light. Okay, but for the mirror, okay, they use a reflection. Okay, they use a reflection of light. Okay, so when we look into a mirror, we can see our image in the mirror. So the image seen in the mirror look exactly the same. How does the image in the mirror form? Okay, so it's actually by the reflection of light. Okay, so the light function because it reflects the light. Okay, so the first one, there are two types of mirror. So the first one is concave mirror, okay, and concave mirror is actually is which curve, right? Which curve? Wait for a moment. Okay, so for the concave mirror, it which curve inwards, okay, so it curve inwards, while the convex mirror it which curve outwards, right? So this is the example like a spoon here, so it concave inward. So the actually the shape of the concave is like this, okay, for the concave mirror, just same like the concave lens, and also its convex is like this, right? Okay, so the concave mirror it produce the image upright and also big. Okay, so and another one is inverted and small. So they can form two types. So later this one we will see how does the image okay being formed. Okay, so from the ray diagram. So you have to learn how to draw. Okay, and for the convex mirror, the image will always small and upright. So remember for the lens, right? For the lens, the convex lens, the characteristic of the image, it has to depend on the object distance. Okay, for the lens, for the convex lens, okay, the characteristic of the image, it has to depend with the object distance. So whether u is equals to f, u is smaller than f, right? U is between F and 2F, okay. But for the mirror, okay, for the mirror, okay, the convex mirror, okay, it doesn't depend on the distance of the object. Okay, so wherever the object is, the characteristic of the image will be same. So that is for convex mirror. And for the concave mirror, they have to depend with the object distance, whether U is equals to F, U between F and 2F, okay, U is at 2F, okay, so it's opposite, right? So means for the convex lens, okay, for the convex lens, they have many types, okay, of characteristic of image. But for the concave lens, only one, okay, only one type of characteristic of image. But for the mirror, okay, it's opposite. Concave mirror, they got many types, okay, many types of characteristic of image. It has to depend on the object distance. Okay, but for the convex mirror, only one type of characteristic. So it doesn't depend on the object distance. Okay. So example of the application of the convex mirror is the side mirror of car. Okay, so this is the, remember we already learned, right, what happened to the light when it's passed through the convex lens. So all the light ray will be converged, okay, into one point that we call it as the focal point. Okay, so what happened if the light ray pass through the convex or concave mirror? Okay, so we will see that one. Okay, so here it says the concave mirror, okay, the parallel rays is converged at the focal point after reflection. So remember for the lens, right? All the parallel rays is converged at the focal point. So it's opposite. Okay. For the concave mirror, okay, now the all the parallel ray is converged at focal point after reflection. So for the convex lens, okay, for the convex lens, all the ray pass through and it will point at one point, right? So for the mirror, now concave mirror actually we point all the light ray to one point that we call it as the focal point. Okay, so for the convex mirror, so this is the uh, ray diagram, okay, for the concave mirror. So you can see all the light ray, okay, it will be reflected back, okay, to one point, and this point we call it as the focal point. So this is the concave mirror. So remember for lens is different, it's opposite, right? Convex lens that actually point all the light ray to the one point that we call it as a focal point. But for the mirror, it's opposite. Concave mirror that point all the light ray to one point. So here you can see it will reflected back. Okay, so this is the focal point. Okay, while for the convex mirror, right? So the parallel is reflected and diverged as it comes from the focal point behind the mirror. So for the convex mirror, all the light ray will be diverged. Then after that, if you make it longer at the back of the mirror here, you can see, right? So let's say if I make it longer like that, so it will point into one point that is called as the focal point. Okay, so it's opposite. For convex lens, okay, all the light ray will be point to one point. We call it as all the light ray will be point at one point. Okay, we call it as a focal point. But in the mirror, the convex mirror, okay, all the light ray will be diverged. Okay, and for the concave lens, right, all the light ray will be diverged. But for the mirror, all the light ray will be converged into one point. Okay, so you need to remember, so don't be confused, right? Okay, so this is the ray diagram. So again, this is called as a principal axis. Okay, and P is also called as the pole of the mirror. Okay, and this is the light diagram, okay, the ray diagram. So you can see it's reflected back. Okay, okay, this one go here and this one go here. So all the light ray converge into one point. We call it as the focal point. Okay, and again, okay, from here to here, okay, from the F to P, we call it as the focal length. Okay, focal length from here to here. So this is for the concave mirror. Okay, for the convex mirror, so this is the principal axis. So P, we call it as the pole of the mirror. Okay, so you can see it's reflected back, right? And also this one also reflected back. Okay, and let's say if we make it the line longer, if we make the line longer, it will be intercept at one point. We call it as the focal point. And F to P, again, we call it as the focal length. Okay, from F to P, we call it as the focal length. Okay, so the parallel ray is refracted and diverged as it comes from a focal point behind the mirror. So you just draw like this, okay, and then you draw it reflected back. Then you just make the line longer, okay, until it intersect. So that point we call it as the focal point. So make sure you know the difference. Okay, so this is for the concave mirror. Okay, all the light ray will be reflected to one point. Okay, reflected back. Okay, so that point we call it as a focal point, and this one, okay, so it will be diverged. Okay, and we make it longer to behind the mirror so you can see there is a focal point there. So the distance between F to P, we call it as the focal length. Okay, so this is actually the concave lens. Okay, for the concave mirror, and this is for the convex lens. Okay, so the term regarding the curved mirror. Okay, so for this one, okay, the line passes through the center of curvature and the pole of a mirror. So this is the principal axis. Okay, where the C and F, right? C and F and also here P. Okay, so this is the line. They pass through all the point. We call it as the principal axis. Okay, while the focal point is point where all the light traveling parallel converge after reflection. So here, this is for the convex lens and this is for the convex mirror. So this is the focal point, and also from here to here, we call it as the focal length. And C is actually equals to 2F, right? So let's say let's say the length is 6 cm. Okay, and this one also should be 6. So C is equals to 2F means C is actually 12 cm. So from here to here is 12 cm. Okay, so C is actually equals to 2F. Okay, and while the pole of the mirror, so this is the pole of the mirror. So remember for this one in the lens, we call it as the optical center, right? So for the mirror, this one we call it as the pole of the mirror here. Okay, and the intercept. Okay, so here we call it as the pole of the mirror, but for lens we call it as the um, optical center, right? Okay, and also the focal length is the distance between F and P. So this is the F. Okay, and the object distance. Okay, so the distance from the object. Okay, from the pole of the mirror to the. Okay, so let's say if I have a concave mirror, so this is my F, and this is my object. Okay, so then later maybe the image is here. So the object, so this is the image. So from here to the, okay, so the pole of the mirror, from here to here is U. Okay, and from here, the center here to here, we call it as V. So this is the object distance. This is the image distance. And C is the center of the concave, right? Center of the concave or convex mirror. Okay, and another one, R. R is the radius, okay, the distance between the pole of the mirror P and C. So from P to C, we call it as the radius of curvature, or we call it as R. Okay, from P to C, okay, from P to C, we call it as the radius of curvature. So C is actually the center of the concave, okay, or convex mirror. Okay, so this is basically how to draw, okay, for the concave mirror. So remember, concave mirror, they have to depends with the object of the distance. Okay, so again, there are three rules actually. Okay, so the first one, right? So is from here, okay, it will be reflected back, okay, to F. Okay, so from here it will be reflected back. So this is, they have to be reflected back because mirror use reflection. So all the light ray when you hit the concave mirror, okay, so it will reflect back to F. Okay, so this is the first one. And the second one from here goes to F. Okay, then after it hit the mirror, so it will be reflected back. Okay, so for me, I will just only number one. I use number one and number two. So this one is for number three. You can use this one also. Okay, so from here you can see it will be pass through. It's just straight line pass through the C, and then after that is reflected back. All right, so I will just use number one and number two. Okay, as long that it shows the intersection, okay, between two light ray, so it's okay already, right? So I will just use number one and number two. So the first one pass through F, and the second one also pass through F and go straight like this. Okay, so this is the ray diagram. Okay, so first one is reflected back to F. Okay, and then the second one is reflected back. Okay, and the last one, it just goes straight line like that. Okay, for the convex mirror, okay, for the convex mirror, right? So the light ray, the first one, the light ray goes here and it will be reflected back. Okay, after it hit the surface of the convex mirror, it will be reflected back. Then you have to make it longer. Okay, it must pass through the F. Okay, so from here, reflected back and make it longer until it pass through the F. Okay, and then the second one, okay, so the second one, right, so just this from the object, it goes straight to T. Okay, it just goes straight to T. Okay, so then you can form, there's an intersection, okay, around here, so they form the image. So I will teach you how to draw for each diagram. Okay, so don't worry. So we just skip this one. Okay, so this is the experiment. Okay. So maybe if we have time, we can do this one. So see, they need a very dark room, and I think they're doing it in during night time because this is the SBP, right? So of course they can do at night. Okay, for the experiment because they have asrama, right? They need to stay there, so they can do anytime. Maybe they're doing this experiment at night. So if darker is better, it's very clear for you to see the image. Okay, so this is the ray diagram. So now we will learn, right, how to draw for the concave mirror. Okay, so I will teach you one by one. Okay, so this is when u is bigger than 2f, means the object distance is bigger than the distance between 2f. So 2f is actually what? Is actually c here. Okay, so u is bigger then 2f. So C is actually equals to 2f, right? So how you want to draw the ray diagram? So the object distance is from here to here. Okay, so your C is from here to here. So you can see your object distance is bigger, right? So let's draw. So after this, you will draw, okay? Okay, so for this one, goes here, okay? Then after that, okay, it will be reflected back. So because mirror use reflection, so it will reflected back to F. Okay, then another one. Okay, so this one, it goes to F. Okay, all right, then it reflected back. Okay, straight line like that. Okay, so this is the ray diagram. Okay, for the first one. Okay, when U is bigger than 2F. Okay, where is the image? So this is the image. Okay, so let's see the characteristics. So remember for the lens, right? For the lens, when the object, okay, when the object and it's not same side, okay, when the object is not same side as the image, right? When the object is not same side as the image, we call it as a real, right? But if the for the mirror, if the object is not same side as the image, we call it as a virtual. So here is virtual and here is real. All right. So it's opposite. So you see, if you remember for the lens, okay, for the lens, if the object, okay, it's not same side as the image, we call it as the real. But in mirror, we call it as a virtual. It's opposite, right? So just remember one, then the another one you can just say, oh, this one is opposite. Okay, so for this one is real and it's inverted. Okay, and you can see the size of the image here is smaller, right? This one is 3 units, this one is only 1.5, so it will be diminished. Okay, so and this is how you draw for the concave mirror. So remember, from this one goes to F, then another one pass through the F, then just go straight. So this is the image that they form. Okay, so for this one, this example, okay, I want you to draw and state the characteristic, okay, of the image. It's the same like I just teach you just now. Okay, 7 more. Okay, 4 more. Hey, Eugene, Nirupa. Teacher, I did wrong. I didn't read the question. Eugene?
Teacher, I have
Yeah.
submitted.
Oh, really?
Yeah.
Did you have two names here? Oh, no wonder. Okay. So I just remove your first one. Alright, so let's see the how to draw for this one. Okay, so for this one is the object when object is actually at 2F. Okay, so mean at C. Okay, so mean they have same distance as C. Okay, so how you want to draw? So the first one just same way. Okay, from here goes to here, right? And it will be reflected back. Okay, goes to F. Okay, and this one from here goes to F. Okay, and then it will be reflected back. Okay, right. So where is the image? So actually, for a moment, I change the color. Okay, so the image is here, right? Okay, so again, this one is a real, okay, inverted, and you can see they have the same size, right? So this is 2 unit, the object 2 unit, the image also 2 unit, so same size as object. Okay, rear inverted, same size. Same size, okay, correct. Diminish. The image should be like this, not like, okay. Maybe because you didn't use the ruler. Upright. No, it's not upright. It's still not finished yet, Eugene. Okay, but this one actually have to be same size. Okay, it's not upright, it's inverted. Upright should be like this. So what is the characteristic of the image? And also the size not same. Okay, maybe this one, what is the characteristic, Avinash? Mm-hmm. What is this, Tava? Here. This one goes to here, then it go back. Right? Here, same size, inverted. Same size. Okay, so for this one is when the object, okay, between F and 2F. Okay, so what will happen to the concave mirror? Okay, so let's try to draw this one. Okay, so the object between F and 2F. Wait, Okay. All right, 6 more. Okay. Nirupa, what happened? Okay, for this one, right? Um, okay, so from here goes here. Okay, then it will be reflected back to F. Okay, and another one from here goes to F. Then is reflected back. Okay, so you can see there's still no intersection, so you just make the line, okay, longer until it intersect each other. So let's see the diagram. The diagram here, what's the characteristic of the image? So the image is here, right? Okay, so now it's still real, okay, inverted, and is magnified. Hmm. Okay. We put same size? No. U is equals to F is same size, but this one is magnified. Okay. Actually, it should be bigger. Never mind. Maybe start for you to draw. Okay. Now what happened when u is equals to f? Okay, means u as the at the focal length. Okay, so what happened? Focal point. Sorry. So what will happen? Okay, so I just show you one example. Then for another one, you have to try on your own. Okay. So for this one, so from here go straight here, right? Then it will be reflected back to F. Okay. And another one, okay, is from C, okay, it goes straight. So because before this, right, when we draw, okay, it goes to F, that another one also have to go to F. But here the diagram, right? Wait for a moment. Okay, so for this one, we cannot pass through the F because the F is not in front of the object. Okay, so what you have to do, okay, so you just take from C, okay, go straight, that, okay, then you see there is no image, right? There is no intersection here. So again, if there is no intersection, what you have to do, you have to make the line longer. So even you make the line longer, you can still find there is no intersection, right, between these two light rays. So means the image is at infinity. Okay, so the image is at infinity. So even the image is at infinity, so we can assume the image will be formed in this part. So mean the image maybe might be virtual, okay, virtual and also upright, okay, and also should be magnified, okay, if the image form, right, because this one the image is infinity, so we don't know where the image will be formed, but let's say it might be the image will be virtual because it's not at the same side of the object, okay, so it's virtual, it's magnified and also should be upright. So that is u is equals to f. Okay, for the next one, u is smaller than f. So it's the same drawing like u is equals to f. Okay, so I want you to try this one. What happens when u is smaller than f?
Teacher, for me the presenter isn't presenting the screen.
Oh, really? Anyone have the same problem like that? Anyone have same problem? Wait, I just me. Oh, maybe because of the internet. I'm happily drawing. Oh, okay. So since you are so happy to draw, okay, I will give you once more time. Okay, once more time to draw.
Okay, now I got it, teacher. Thank you.
Okay. Okay, 1 more minute. Okay. Two more. Who is it? Kisha and Nirupa. Okay. Teacher, I already passed up. Alright. We have two names, is it? Okay, so how you want to draw for this one? So again, from here goes to here, then it will be reflected back to F. Okay, and another one is go to from C, goes to the head of the arrow there. Okay, then again you can see there is no image being formed, there is no intersection. So what you have to do, you just make it the line longer, okay, until it intersect with each other. Yeah. Okay. So let's see the image. Okay, so this is the image. Alright, so the image is virtual, okay, because it's not same side as the object. Virtual upright, and another one is magnify. Virtual upright magnify. Virtual upright magnify. Virtual upright magnify. Right? How you get magnified, Eugene? Um, it's supposed to be from C, right? Then you can get the image is magnified. Okay, your characteristic is correct, but your ray diagram is wrong. Tava also, okay, should be that. Mm-hmm. Alright, so we already draw a 5-ray diagram for the concave mirror. So remember, concave mirror have to depends, okay, with the object distance. So this is the summarize. Okay, so this is the position where you can get the real or virtual image. So for real image, when u is bigger than 2f, when u is between f and 2f, when u is equals to 2f for the real image. Okay, and for the relationship, so this one, the less the object distance, the further the image distance. So this one we already no, that one is for the lens, right? To investigate the image distance and the object distance. So this one also same. Okay, and you can see the relationship between the object distance with the object distance with the size of the image. So it's inversely proportional. So when you decrease the object distance, right, the image will be bigger, right? So you can see when it's approaching to f, okay, so the image becomes bigger, right? And when u is smaller than f, the image is magnified and is visual. Okay, now the next one is for the convex mirror. Okay, so I will teach you how to draw this one. So remember for the convex mirror, okay, for the convex mirror, so there is only one ray diagram. So it doesn't matter where's the object, okay, doesn't matter where's the object. The characteristic of the image will always be the same, right? Okay. This is the application. Okay, so another application for the mirror. So there's another type. Actually, there is a plane mirror. Okay, but this one you already learn when you're learn in science PT3. I can't remember, maybe form 1, form 2. Okay, so you learn about the plane mirror. So for the plane mirror, okay, we use it in the electrical instrument. So if you see the voltmeter and the ammeter, you can see there is a strip of mirror. Okay, a strip of mirror. Okay, below the scale. So what is the function actually? The strip of mirror is actually to avoid the parallax error. So whenever you read the reading for the voltmeter, you have to see that the image, okay, the image that been formed, okay, by the pointer, okay, it must be on the it must be in, I mean that there is no, like this one you can see the line here, this is the image and this is the pointer, right? So you have to make sure that the pointer and the image is parallel to each other. Okay, so that means that there is no, the image is here, the pointer is here, so the pointer must be on top of the image, then you can read. So if it happen like this, means it has a parallax error. Okay, so it's actually this one to avoid parallax error when you read the voltmeter or the ammeter. So this is the use of plane mirror. Okay. Alright, so now we learn how to draw for the convex mirror. Okay, so remember it doesn't matter where is your object. Okay, so the way to draw and the characteristic of the image will always be the same. Okay, so let's try to draw this one. So from here, okay, so since they use the reflection, right? Okay, so it will be reflect back like that. Okay, then this line, we make it longer until it pass through the F here. Right. So after that, from C, and this one you have to add one more. Okay, so you have to add C here. D is F, F is 4, right? So means the C is here. Okay, so you have to add one more because this one need to pass through the C there. So from here, it goes to C. Okay. So again, right, from here, he reflected back. Okay. And you have to make this line longer and you pass through F. And another one from here, go straight to C, right? So you can see the image form is here. Okay, so this one is virtual. Okay, diminish. And another one is upright. Okay, so this one doesn't matter where is the object, whether at C, between F and C, okay, or at F, or before F. Okay, the way to draw is the same, and the characteristic of the image also will be the same. So from here, okay, reflected back. Okay, and this one you just make the line longer until it passes through the F. And another one from here it goes straight to C. So this will be the image, right? Okay, so the next one, this one I already told you. This is the strip of mirror, right? That we put, okay, below the reading, okay, below the scale of the emitter. So this one, how to overcome this problem? So you have to read when the pointer is overlapped with the image of the pointer. Okay, and this also the application. So the object, okay, is between focal point and mirror. A magnified virtual image is created. Okay, so this is when u is smaller than f. Okay, so the concave mirror is used to create and magnify an upright image of the face, because for the convex the image will always be diminished. Right, so if you want to create the bigger image, so you have to use the concave mirror. Right, so this is the difference between the plane mirror and also concave mirror. So if you use a plane mirror, so this is the image that will be formed, is smaller, right? So if the concave mirror, right, is the image is magnified. Okay, so for the makeup, the lady's face must be close to the concave mirror, so the object distance has to be less than the focal length, right? And another one is the transmission of the radio wave signal. So the shape of the reflector should be concave mirror. So where is the location of the signal receiver? So should be U is equal to F. Okay, where is the at the focal point? It means the object should be the signal receiver should be at the focal point. So this one is because the incident wave from the satellite are parallel and we focus at the focal point after reflection. Right? So this one when U is equals to F. So means all the incident wave from the satellite can focus, okay, at one point, okay, after reflection. Okay, so this is the example of the satellite. Okay, and then the next one is the reflector of the torchlight, right? So this one also they use a concave mirror. Okay, where is the location of the bulb? Light bulb should be at the focal point. Okay, so it just same as the same as the signal receiver. Okay, should be at the focal point also. Okay, so how does the reflector function? So all the light ray from the bulb at F, okay, hit the reflector and will be reflect, okay, parallel. So we can see a distant object. So all the light ray will be reflected back. Okay, all the light ray will be reflected back. So from here, light goes from here, it will be reflected, and this one also will be reflected. Okay, so then it can produce the parallel light ray. Alright, so this is the example. Okay, normal, high beam, low, high beam. Okay. So when the bulb, okay, when the bulb at F, light reflected parallel to see distant object in front. Okay, so this is when we use the high beam, right? When you use the high beam, okay. So all you can see the light is in parallel, so meaning you can see the distance object. So this is the comparison, right? Low beam and high beam. And this one is for the dentist, right? So they use U is smaller than F. So they can see the image is virtual, upright, and magnified. And for the convex mirror, so what is the function of the convex mirror? So this one is actually there should be some note here. Okay, so this is for the car side mirror, right? So they use the convex mirror. Why? Because the field of vision is bigger. So they can see, the driver can see at the back and also at the side of the car. Okay, so normally we use a convex mirror for if you need the wider view of vision. Okay, so just now is the dentist mirror. Okay, so the type of the type of mirror is used is concave mirror, and U is smaller than F, because you know when U is smaller than F, the image we form is virtual, upright, and magnified. Right, so you can see it clearly lah, right, because the image is bigger. Okay, now is for the car side mirror. So we use a convex mirror because the field of vision is wider. Okay, and this one is the mirror at the sharp corner. So this one also we use a convex mirror. Okay, because it has the wider field of vision. Okay, and the light from, how does it use? Okay, to see the incoming car. So the light from the car ahead will be reflected back. Okay, by the mirror to the driver. Okay, so you can see the upright and small image and wider field of vision. So actually the light, okay, come from the incoming car. So the light, let's say the light hit the mirror here, so it will be reflected back, okay, to the driver. So you can see actually there's a car coming. And this is for the supermarket. Also, they use for the safety purpose. Okay. So this one is actually it can form. It has a wider field of vision, right? So it can see around the market if there is a theft. Okay, if someone want to take food or something. So the image we form is always virtual, smaller, and upright. So you can see the whole shop here. Okay, so the image in convex mirror are always smaller. Okay, so we already see just now convex mirror has only one type of diagram or ray diagram, and image in concave mirror are always bigger. Okay, but this one have to depend on the object distance. If you want to make it bigger, means the U must be smaller than F. Okay, and this is the image formed by the plane mirror and the convex mirror. So you can see for the convex mirror, the field of vision here is much wider than this one. Okay, so this is actually the questions. Okay, so actually this one, I just want to start from this one. Okay, so can you try to answer this one? Still have 15 more minutes. For concave mirror, so which of the correct reflection of light from for concave mirror? Okay, convex mirror and concave mirror. Okay, two more. Okay, Avinash, Tava. A, B, B, B. Okay, so here is a concave mirror. Concave mirror is actually, it will be reflected back, right, to one point that we call it as the focal point. So the answer should be B. Okay, A is actually for the convex mirror, right? So the answer is B. Okay, for the next one. So it says here what the characteristic of the image form. So this is the concave mirror and U is the object distance is 20 cm. So mean U is equals to 2F, right? Because your F is 10 means 20 means U is equals to 2F because 2F 2 times 10 is 20. So what happened when U is 20 cm? Okay, means the object is at 20 cm. So this one you already draw just now. Okay, two more. Eugene? Okay, so U is equals to 2F, right? Because F is 10, your U is 20 means U is equals to 2F. So let's see the image that have been formed. Okay, this one you already draw. Okay, U is equals to 2F. Right, this one, right? No, wait for a moment. I find the right. This one, no. Maybe before. Yeah, this one. U is equals to 2F, right? So you see the image is real, inverted, then same size. Okay. So the answer should be A. Okay, real, same size, inverted. Okay, very good. Okay, so this is the last one. So tomorrow we just discuss the question from the 6.4, 6.5, 6.6. Okay, so I remember we still not discuss it yet. So we only discussed the three, not tomorrow, on Wednesday. So on Wednesday we just discussed the questions. So we are finished now. So when the school open, make sure all of you already have the module. Okay, so for those who still didn't take, please go and take. I hope it's still there. Okay, if not, you have to photocopy on your own. Teacher, when is the exam? The exam is on 29 November. It's not an exam actually, it's PBD summative. Okay. But it's the same like exam lah. Okay, you cannot copy. November. But for that one is for group 1. For group 2 will be the next week. It will not be at the same time. The paper will be on your table the moment you masuk kelas. Yeah. 29 November is like 1-8. Yeah, maybe you already, like we can do 2 experiment, I think, until 29, then 2 weeks. Yeah, I think we can only do 2 experiment. Because you are, like have to bergila kan. So tak boleh nak buat eksperimen banyak. Okay, so U is smaller than F, virtual and bigger than object. Okay, this one goes here, right? And then this one C will pass through the F, right? So it will form here. So virtual and bigger. Number 5 is C. Group 1 and group 2 different set. Only for physics. Teacher, but PBD no. Cannot see the book, Kitiga. No, cannot see the book. The question for physics is different set, but for other subject I'm not sure. Actually, Mr. Wong said just use one set, but like if one set maybe the kesahan dia tu, maksud saya dia punya soalan tu mungkin nanti tak adil untuk kumpulan satu kan. Sebab awak ada yang baik dengan kawan awak, nanti bagi tahu soalan apa kan. Ada kan. Jadi saya tak nak lah macam tu, so saya akan buat different set. Untuk group 1 satu lain, group 2 lain. So you think is fair lah, okay, for each group. But that is for me, but I'm not sure other subject. Okay, it depends on the subject teacher. Okay, and for kimia, what I know, there will be online test, if I'm not mistaken. Okay, and I don't know, I'm not sure about the subject because only like 6 or maybe 9 subject. And remember, for those who taking maths, you are not taking a maths exam. You only be taking at maths because at maths we slash with maths. Okay, so if you take maths, so you only go to maths, and for those who don't take maths, they will take maths. Okay. So the way how to do it is up to the subject teacher. So you can ask, but only for this, the one that I mentioned just now, BM, BI, sejarah, at maths, pendidikan Islam, pendidikan moral. If I'm not mistaken, another one is physics. Okay. Only that subject. Okay, that will be tested. Others, it depends on the subject teacher, how to conduct, or maybe don't have. Okay, so only that 6 subjects that have a PBD summative. Teacher, 2 papers or 1 paper? Only 1 paper, 1 hour and half. Okay, but for physics, I will combine paper 1 objective, paper 2 structure, and also you have essay also. Okay, this is actually, like maybe to you make sure that you're familiar with the SPM format, but actually it's not full. But what I can say, you have an objective, you have a structure, and you have an essay. Section B and section C. Okay, and what subject will be, what topic that will be come out? I try to make all the topic. Okay, but later that one I will tell you later once I already set up the questions. Okay, for physics. For other subject, please ask your own teacher. Okay, because every teacher they got different. For mine, I will make 2 set different, so it will be fair for each group, right? So any other question you want to ask regarding for your exam? And I just want to ask, is it just, like be honest to me. For 2nd November, any of you will come to school? Or still not decide yet?
Teacher, I think the online classes we can join, but physical, I think most of us won't come.
Yeah, because just now when I asked weekend to ask, right, on that say like 5 students will come. Okay. Then I know, I understand, because you are still not like, not enough there should be like 14 days, right, after your second vaccine, then it will be effective, right? So means on 2nd November, who is actually will come to school? If you don't come to school, just make a letter. For one, I know not all of you will not come. For second,
The
all will
teacher, is
come.
it for first week group
Yes,
or second week group?
first week. On 2nd November is first week. Second, Eugene, you will come.
I think I'm on second group.
You are first group, right, Eugene? Check first. You are first group. Eugene, I think I put by the list until Kritiga, I think, in the first group, and then weekend is on second group, if I'm not mistaken. Okay, so make sure you check your group carefully. Don't come like, I'm your second group, then you come in the first group. Okay, so make sure you come. You check your name first, whether your first week or second week, right? Okay, so never mind. Maybe you still not decide yet. So 1st November, all will not come. Please let your subject teacher, okay, know that you are not coming to school on 1st November because of the vaccine. Teacher, next year you are form 4. You will be form 4 until February. March, then you go to form 5. Okay? Yeah. Until February. Then March you will go to form 5. But I think your SPM also will be, like on not in the end of the November or December. Will be next year also. Yes, I think so. Because you start on March, right? So you already waste 3 months there. Okay. So you will be taking your SPM on when you are 18, not 17. Okay. So I see you on Wednesday. Okay. So take care, everyone. Okay. So bye.
Thank you, teacher.
Thank you, teacher.
Okay,
Thank you,
welcome.
teacher. Bye.
Yeah, teacher.
Bye.